Today I am going to discuss all about Pythagoras theorem of your exercise 6.5, and in the textbook it is theorem number 6.8. Before 6.8 Pythagoras theorem, some very important concept about right triangle we have to understand. Suppose you are having a right angle triangle. Here, look at this figure, what I am going to talk today. The name of this triangle is ABC. I am writing here A, here B and here C. Suppose this angle is a right angle. This time the right angle I have taken at here at point B due to some reason. One thing I want to show you today. In this right angle triangle ABC, if you are drawing a perpendicular from B, suppose you are going to draw a perpendicular down there. Okay, so here you have drawn a perpendicular on this side AC. As you are aware that in this right angle triangle, if a angle B is a right angle, that means AB may be the base, BC may be the perpendicular and AC is hypotenuse. It's your choice that you are treating BC as base and AB as perpendicular, but AC will be always the hypotenuse. Suppose name of this point is D. So here in a right angle triangle, from the vertex at perpendicular, if you are drawing another perpendicular, okay, on the hypotenuse, then you are having two triangles, and this two triangle is always similar to the triangle ABC. That means what I am going to talk you about, that triangle ADB, here triangle ADB is similar to triangle ABC. Triangle ABC, and one more triangle you are having, triangle BDC. Triangle BDC, it is also similar to triangle ABC. Okay, so this thing you keep in your mind, that when you are drawing, if a perpendicular is drawn from the vertex of a right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle and to each other. This is all about theorem number 6.7. You can see in your book the theorem is 6.7. The statement of the theorem is 6.7, and what is the mathematical gist of that theorem, that I have written there. So you need to note down theorem number 6.7 from your book and write down the mathematical explanation of this theorem. So here all the triangles, these two smaller triangle ADB, you can see triangle ADB is similar to triangle ABC, and again triangle BDC is similar to triangle ABC. This is all about theorem 6.7. You need to write down the statement, and also you are advised to write the meaning of this theorem mathematically, which I have written over there. After understanding it, we will talk about Pythagoras theorem. You all know Pythagoras was a great mathematician. He discovered so many things in maths, but most prominent and popular thing is Pythagoras theorem. In your book you can see the photo of that person, that personality. Actually, the story is that the Pythagoras theorem is discovered by Buddhayan. That was he was a great Indian mathematician. He discovered this Pythagoras theorem, but the credit goes to Pythagoras because Buddhayan, about 800 BC, he has discovered this theorem, and the statement whatever he has written there in his book, the diagonal of a rectangle produced by itself the same area as produced by its both sides. The gist is like that only, but it was helped Pythagoras to give his theorem, and actually both the theorem's concept is very same. So some people also known this theorem as Buddhayan's theorem. That means Pythagoras theorem and Buddhayan's theorem, both the theorems are similar, both the theorems are same, but we have to study all about Pythagoras theorem because his name is more popular than Buddhayan. So we will talk all about this theorem, and it is theorem number 6.8, and today I am going to give you the proof of this theorem number 6.8. In the statement you can see, in a right triangle the squares of hypotenuse. What is the statement? In a right triangle, in a right triangle, in a right triangle the square of hypotenuse, the square of hypotenuse is equal to the sum of the squares of square of the other two sides, the other two sides. This is the statement of this theorem, and you all are aware about this statement. The meaning of this theorem is what? You are aware that the meaning, if I am explaining the meaning of this theorem, it is very clear. Suppose you are having a right angle triangle ABC. At B it is right angle. Then you know that AB square plus BC square is always equal to AC square. That is, you are aware, okay, you are aware P square plus B square equal to H square. In short, we are writing P square plus B square equal to H square. This concept you are using from class 7 onwards. This is the meaning of this statement. Mathematical explanation, if I want to write over there, then I will write it like that: AB square plus BC square. Here you can see AB is perpendicular, BC is base, and AC is the hypotenuse. So P square plus B square equal to H square. Now we will talk about the proof of this theorem. So first of all you have to understand it, and I know that each and every student who is studying in class 10 is aware about the statement of this theorem. Now I am talking about the proof. We need to prove this theorem. Okay, so let us prove this theorem. First, how to prove? So in proof, first of all you need to draw a right angle triangle. Just see, I am going to draw a right angle triangle like that this time, because it will help us to understand many things. A, B and C. Suppose ABC is a right angle triangle and it is a right angle at this point B. Now I am going to draw a perpendicular from B to this side AC, this side AC, and suppose this is, its name is D. So BD is a perpendicular which is drawn on the side, AC, and you are aware here that AC is the hypotenuse of this right angle triangle. So what is given? What is to prove? Let me write. Okay, so let triangle ABC is right angle at angle B. Right angle at B. Right angle at angle B. Now we need to prove. What to prove? What to prove? It is to prove that AB square plus BC square, AB square plus BC square equal to AC square. This you need to prove actually. Okay, or you can write AC square equal to AB square plus BC square, no problem. Now what construction I have drawn? Write down that construction. The construction is draw. What to draw? BD perpendicular to AC. This is our construction. What construction I have done? I have drawn BD perpendicular to AC. This is drawn. Then we will start the proof of this question. So till here you have to copy down first, because I will clean this part now. Okay. So I am going to clean till here. So what is given? What is to prove? This you have written already, I hope. After writing it, now I will talk about the proof of this theorem. So now I will talk about the proof. As we are aware that triangle ADB, you can see triangle ADB. Since triangle ADB is similar to triangle ABC, can you just by from theorem number 6.7, this is from theorem, you can write here from theorem 6.7, no problem, from theorem 6.7. It is clear that triangle ADB is similar to triangle ABC. Both the triangles are similar. That means it is clear that their side will be proportional. That means AD upon AB, AD upon AB, AD upon AB. You can see AD is the base of triangle BDA. AD upon AB is equal to AB upon AC. AB upon AC. Why it is written like that? AD is the base of triangle BDA and AB is the hypotenuse. That means base, you have taken the base upon hypotenuse of this small triangle BDA. Like that, the base of this triangle ABC is AB and hypotenuse is AC. So corresponding sides if you will take, then AD upon AB is equal to AB upon AC. Now it is clear that AB square, if you will multiply it as cross, you will have AB into AB, means AB square equal to AD into AC. That you can write there, and this is your statement number first. You can write there first. Again we will take another pair of triangle. Okay. Also we are having triangle BDC. This time BDC, triangle BDC is similar to triangle ABC. Now you take the another triangle, that is triangle BDC, and triangle BDC is also similar to triangle ABC. Again this is from theorem number, this is from theorem 6.7 itself. Okay. Their corresponding sides will be proportional. That means if this is similar, then corresponding sides are proportional. That means CD, this time I am taking CD upon BC, CD upon BC. CD is the base and CD is the base of this triangle BDC, and BC is the hypotenuse of this triangle BDC. Then it will be also equal to BC upon AC. BC upon AC. CD is the base of this triangle BDC and BC is the hypotenuse of this triangle BDC. In the triangle ABC, BC is the base this time and AC is your hypotenuse. Now if you will cross multiply it, then what you will get? You will be getting BC square, multiply BC and BC, you will be getting BC square is equal to CD into AC. You are getting CD into AC. This is your relation number second. So till here, first of all, you copy down, then I am doing the remaining part of this solution. Okay. Actually, what I will do now, I will add first and second. Now I will write adding first and second together. So when you will add first and second, what will happen? Let us see. Or okay, I can write there. There are some space. I hope that you have written this part. So let me arrange it. The space. Okay. Now adding first and second together. Now I am going to write adding first and second together. First and second. Okay. If I will add first and second, in first you can see AB square and here it is BC square. So I can write AB square plus BC square is equal to, right side it is AD into AC. I am writing AD into AC and plus, wait, you will not be able to see. Here I am writing AD into AC plus CD into AC. CD into AC. Now here one thing is common that I can take, AC is common, and here AD plus CD you are having. In the figure, if you will see, AD plus CD is giving you AC. That means I can write here AC. So AC and AC becomes AC square. You can write here AC square. So it is clear that AB square plus BC square equal to AC square. Therefore, I can write there AB square plus BC square equal to AC square, and it is proved that we want to prove. So this is the proof of this Pythagoras theorem, and this time it is in your syllabus that they have told to prove this theorem. So you have seen how to prove this Pythagoras theorem number 6.8. The theorem number 6.8 was like that. Okay. So just you copy down and practice this theorem how I have proved. Now I have to talk about theorem number 6.9. Actually in 6.9 proof is not required. We will be understanding the statement in a triangle. If a squares of one side is equal to the sum of the squares of the other two sides, then the angles opposite to the first side is a right angle. That is actually the converse of this right angle triangle. Okay. So you need to write down this theorem number 6.9 also, and then you write its mathematical explanation of that theorem. Now we will see some question from exercise 6.5, and we will see that how this theorem is helping us in doing these sums of exercise 6.5. I hope that you have written it. Okay. Okay. So this was the theorem number 6.8 onward that you have seen already, Pythagoras theorem. Now in exercise number 6.5 you will see the application of this theorem. So here I am taking question number 1. You can see exercise 6.5 question number 1 is there, that is sides of triangles are given below. Determine which of them are right triangles in case of a right triangle, write the length of the hypotenuse. Okay, so you are already aware that in a right angle triangle, hypotenuse is the longest side. Okay, hypotenuse is the longest side. So you need to check it that it is right angle triangle or no. How to check? Question number 1, your measures as written as 7 centimeter. Here it is written 7 centimeter the first side, then second side is written as 24 centimeter and your third side is written as 25 centimeter. That means you can, if you will guess it, then you can easily say that 25 may be the hypotenuse, maybe. So how you will be checking? First of all, you have to check like that, 7 square plus 24 square. First of all, you find this 7 square means 49, and when you will multiply 24 and 24, it will give you 576, and after adding this number you will have 625. Now 625, and then you have to check the third side, that is 25 square. It is also coming 625. So here from first and here the result is second. From first and second you have seen that we have seen that 7 centimeter square or unit you need to write or not, it's depending upon you, there is no problem. Basically I am checking that the sum of the square of two smaller sides should be always equal to the square of the third side, and you have seen here this relation is there. That means the given measurement, therefore the given sides make a right angle triangle. You will write, therefore the given measures, the given measures gives a right angle triangle, measures gives us a right angle triangle, okay, and its hypotenuse is 25 centimeter. They have told to with hypotenuse, triangle with hypotenuse 25 centimeter. With, we will write hypotenuse 25 centimeter. That means you have already identified the hypotenuse. You know that hypotenuse is the longest side in a right angle triangle. So you will be finding like that, you will be checking like this, that the measures are for right angle triangle or not. Now I guess that you will be applying this concept in checking question number 1. So 1 number question I am leaving on you, and today itself you need to do it. Okay, do all these questions. Now I am talking about question number 2. Okay, I am talking about question number 2 there. So there in 1 number there are 4 questions. How I have done first number question, like the same way you need to do rest of the other questions there. So I am talking about question number 2 now, so that you can have the idea and you will get confidence in doing sums. PQR is a triangle, right angle at P, and M is a point on QR such that PM perpendicular to QR, so that PM square equal to QM into MR. Very good. Here PQR is a triangle, right angle at P. Okay, so I am going to draw a right angle triangle like this. Okay, and its name is written PQR. Okay, so I am going to draw the triangle like that this time. Okay, and here PQR, and in this PQR, in this triangle PQR, at P and M is a point on QR. Okay, on QR, M is a point on QR such that PM is perpendicular. Now I will draw a perpendicular there like that. See, this is a perpendicular drawn there here, and its name is written as PM. Okay, PM is perpendicular on the side QR there. Okay, okay. So that PM square equal to QM into MR. Okay, so let me write in a right angle triangle, and here it is clear that this angle is also a right angle. That means RPQ is a right angle. That means 90 degree. In right angle triangle QPR, in a right angle triangle QPR, PM is perpendicular to QR. It is given there. Okay, that means angle P is 90 degree. It is clear. That means PM is perpendicular to QR. To prove, we need to show, that means to prove. What to prove there? PM square. We need PM square is equal to QM into MR. This you want to prove there. Okay. So this is the given thing, and this is to prove. No need to construct anything here. You can prove it directly. So in proof, what you need to write there? In proof, first of all we will be writing that since triangle PMQ is similar to triangle RMP. Sorry, similar, not congruent. Triangle RMP. Here PMQ is similar to triangle RMP. That you are aware that both this small triangle, okay, RMP and QMP, both the triangles are congruent to each other, that we are aware. Okay, the reason you need to write, if a perpendicular is drawn from the vertex of right angle to the hypotenuse, then triangles on both sides of perpendicular are similar to each other and to whole triangles. That means you can give the reference of your theorem number 6.7 that we have just discussed. So both these triangles are similar. That means their corresponding sides are proportional, and here PM upon RM is equal to MQ upon MP. That you can write. If the two triangles are congruent, that means their corresponding sides PM upon RM is equal to MQ upon MP. That you can write. Now if you will multiply it in cross, then PM and MP will give you PM square. That will be written as, then you can write PM square by PM square or MP square, whatever you want to write. I can write PM square is equal to MQ into RN. MQ into RN. If you will cross multiply there, then you can see PM and MP both are the same thing. So if PM and MP will be multiplied, you can write it PM square and here MQ into RM. And I think that it was given for proof. Corresponding sides of similar triangle, you can write here, you can write corresponding sides of similar triangle. Corresponding sides of similar triangle are always proportional. Similar triangles, that reason you can write it like that, that corresponding sides of two similar triangles are always proportional. So like that you can prove, and till here it is proved, the question over. Okay, so this you have seen, question number 2 is done like that. So in the same way you can be able to do the remaining questions, and those questions, this time I am taking one more question there, that is question number 3. That is question number 3. Let us see one more question, question number 3 now. I hope that you have copied it. Okay, let me show you question number 3. Question number 3 is there like this. Question number 3 is, in the given figure ABD is a triangle right angle at A and AC is perpendicular on BD, so that there are 3 relations. Let us discuss this. First of all, I have to draw the given figure. The figure is like that. Okay, so you have to copy down the figure first, then here it is written A, then B, then here C, and AC of perpendicular is drawn there. Here it is clear that angle A is a right angle, angle A is also there a right angle. Okay, so in the given figure ABD, here it is D, ABD, and here it is C. So ABD is a right angle triangle and right angle at angle A. So what is given? First of all, what is given there? It is given for all the question. It is given that given triangle DAB or BAD, whatever I want to write, I can write BAD is a right angle at angle A. Okay, another thing is given, and AC perpendicular to BD. AC perpendicular to BD. It is given for all the question. Now to prove in first number I have to prove many things here. First number you need to prove AB square is equal to BC into BD. First thing I have to prove, there are 3 questions, all the questions are very similar. Okay, first of all, for first question I will write the solution. What I may write here, that I need to take here 2 triangles. Triangle BAC, since triangle BAC is similar to triangle BAC, you can see triangle BAC is similar to triangle BDA. Triangle BDA. Okay, triangle BAC is similar to triangle BDA. Both the triangles are similar. Therefore, their corresponding sides are proportional. That means BA upon BD is equal to, you can see BA and BD, BA upon BD will be equal to BC upon BA. That will be equal to BC upon BA. It is BC upon BA, that you can see the corresponding sides are proportional. Okay, this is sides are proportional. You can write there corresponding sides are proportional. The reason you will write corresponding sides are proportional. That you can write there. If 2 triangles are similar, that means their corresponding sides are proportional. Now just you cross multiply this. then you will have BA, BA, you will multiply, it will give you BA square, and that is equal to BC into BD. That will give you BC into BD. So it is proved. It is proved. So these are the application of Pythagoras theorem and its converse that can be used in doing those questions again for second number. To prove first number question proved. Now if I want to prove the second number, in the same way you can prove second number also and third number also. So just one I have done for you all, and second and third I am giving you that you as a homework you can prove, and remaining questions I am going to send you so that you can do 4 onwards. There are few more questions are there and that you need to do by yourself, that I will try to send you the solutions and you do it. Thank you for today.